This is day 16 of Advent of Cyber 2025, and this challenge is called Forensics, Registry Furensics. TVFC is under attack. Systems are exhibiting weird behavior, and the company is now feeling the absence of its lead defender, McSkitty. However, McSkitty made sure the legacy continues. McSkitty's team, determined and well-trained, is fully confident in securing all the systems and regaining control before this big event, Sockmas. They have now decided to conduct a detailed forensic analysis on one of the most critical systems of TVFC, Dispatch Server 1. The Dispatch Server 1 coordinates the drone-based gifts delivery during Sockmas. However, recently it was compromised by King Malhead's bandits of bunnies. TVFC's defenders have decided to split into specialized teams to uncover the attack on the system through detailed forensics, while some of the other team members investigate logs, memory dumps, file systems, and other artifacts. You'll work to investigate the registry of this compromised system. So for this challenge, we will understand what the registry is and what it contains, dive deep into registry hives and root keys, analyze registry hives through the built-in Regedit tool, and learn registry forensics and investigate through the Registry Explorer tool. So for this challenge, we will start the virtual machine and we'll open up in split view. Windows Registry. Your brain stores all the information that you need to function effectively. This includes how should you behave, what should be the first thing you would do after waking up, how would you dress yourself, what are your habits, what happened in the recent past. These are just a few things. Your brain knows pretty much everything about you. It's just like a database storing the human configuration. Windows OS is not a human, but it also needs a brain to store all its configurations. This brain is known as the Windows Registry. The registry contains all the information that the Windows OS needs for its functioning. Now, this Windows brain, the registry, is not stored in one single place. Unlike a human brain, which is situated in one single place inside the head, it is made up of several separate files, each storing information on different configuration settings. These files are known as hives. So let's take a look at all these hives in the table below. First column contains the hive name. Second column contains the types of configuration settings that each hive stores. And third column contains the location of each hive on the disk. So there's system. This contains services, mounted devices, boot configuration, drivers hardware. And this is in Windows System 32 config system. We have security, which stores local security policies, order policy settings. And this is in security. We have software. This contains installed programs, OS version, other info, auto starts, and program settings. This is in software. SAM has usernames in the metadata, password hashes, group memberships, account statuses. This is in SAM. We have ntuser.dat. These store recent files, user preferences, and user-specific auto starts. This is in users slash the user's username slash ntuser.dat, and then user class.dat. This contains shellbags and jump lists. This is in C users, the name of the user, app data, local, Microsoft, Windows, and user class.dat. The configuration settings stored in each hive listed above are just a few samples. Each hive stores more than these. Now that you know where these registry hives are stored, you may be tempted to double-click and open these files from their respective locations to view the data that they contain. But here's the twist. These registry hives contain binary data that cannot be opened directly from the file, so double-clicking them would only display things you won't ever understand. Then how can we possibly view the registry data? Windows OS has a built-in tool known as the Registry Editor, which allows you to view all the registry data available in these hives. You can go ahead and open this tool by simply typing Registry Editor in your search bar. So as you can see in the Registry Editor, screenshot above, these are the same file names, so machine, user, and more. So Windows organizes all these into structured root keys. Instead of seeing the registry hives, you would always get these registry root keys whenever you open the registry. Now, which registry key contains which registry hive? Answer question. We have to get the table below. So system is in local machine system, security is in local machine security, software in local machine software, SAM, local machine SAM, end user data is in users, SID, and H key current user, and user data is in users, then software classes. In the table above, you can see that most of the registry hives are located under the H key local machine key. You can verify this by clicking on the little toggle area on the left side of the HKLM key in the registry editor. As you can see, the system, software, security, and SAM hives are under the HKLM key. User dat and user class dat are on HK users and HK current users. So the other two keys, classes root and current config, are not part of any separate hive files. They are dynamically populated when Windows is running. So far, we have learned what the registry is, what is located, and how to view the registry through the registry editor, which displays the registry keys backed by these registry hives. Now, let's see how we can actually extract information from the registry. Think of it like navigating to different files in the File Explorer. If you know the path where the file is stored, you can go directly to that location to find the file. So let's take a look at a few examples. So I'll finally open up regedit in here, so registry editor, and we'll be navigating to this path. In the top here, we should be able to place computer with the name of the key, and then that navigates to that location. So we are in enum and USB tour, which we don't seem to have. Okay, well, carry on from here. So open the registry, navigate to the path. Here you'll see the USB device's information, make, model, and device ID. Each device will have the following: main subkey, that is the identification of the type and manufacturer of the USB device. Subkey under the above. So for example, that represents the unique devices under this model. So now example 2 is view programs ran by the user. We'll do the same thing here. Place computer with. We'll do the same thing here by copying this and putting that into here. So this one is available, but it doesn't have any keys yet. But in the screenshot, you can see A, B, C, D, E, F, and it's got the value as which file was opened. So now Registry Forensics. Since the registry contains a wide range of data about the Windows system, it plays a crucial role in forensics investigations. Registry Forensics is the process of extracting and analyzing evidence from the registry. In Windows digital forensic investigations, investigators analyze registry, event logs, file system data, memory data, and other relevant data to construct the whole incident timeline. The table below lists some registry keys that are particularly useful during forensic investigations. So this first key, which has user assist, stores information on recently accessed applications launched via the graphical user interface. We have typed paths, stores all the paths and locations typed by the user inside the Explorer address bar. We have app paths, stores the path of the applications. Word wheel query, stores all the search terms typed by the user in the Explorer search bar. We have run, which stores information on the programs that are set to automatically start up programs when the user logs in. We have recent docs, which stores information on the files that the user has recently accessed. Computer name, which stores the computer's name or host name. And uninstall, which stores information on the installed programs. So numerous other registry keys can be used for extracting important evidence from a Windows system during an incident investigation. Investigation of these registry keys during forensics cannot be done via the built-in registry editor tool. This is because the registry analysis cannot be done on the system under investigation due to the chance of modifications. So we collect the registry hives and open them offline in our forensic workstation. However, the registry editor does not allow opening offline hives. The registry editor also displays some of the key values in binary which are not readable. So to solve this, there are some tools built for Registry Forensics, and in this task you'll use the Registry Explorer tool, which is a registry forensics tool. It is an open source and can pass the binary data out of the registry. You can analyze it without the fear of modification. So on our desktop we have the registry hives directory, which we can open up, and we have all different registry hives here. We now need to launch the Registry Explorer tool, which is the green icon in the taskbar. Okay, so with Registry Explorer open, we go to File, Load Hive, and we want to go to the desktop Registry Hives, and then open this directory, and we want to select the desired hive file system, hold Shift, then open to load associated transaction logs. So it's saying, so select system and hold Shift and open. Transaction logs have been replayed, and in memory, hive has been updated. Hive on disk has not been updated. Okay, so you have to do that for each individual hive apparently. So that seems to be fine now. So investigating registry keys, uploading the system hive, you can navigate to the specific registry keys for investigation. So saying navigate to root, control set 001, control computer name and computer name. And for this, we see this key here, where we see dispatch server 1. So now they understand how to load hives and navigate in Registry Explorer. You're ready to begin your forensic investigation and uncover evidence of the TBFC intrusion on the dispatch server. Note, the abnormal activity on dispatch server 1 started on 21st of October 2025. The table given in the Registry Forensics explanation is going to be a friend. So what application was installed on the dispatch server before abnormal activity started? So yeah, I assume that would be stores information on the install program. So this was the system one, so I'm assuming we have to bring up the software one. So there's software, shift open, and inside software, assume root the Microsoft Windows current version that we are looking before. Now down here, Windows, current version, and install. I'm going to open this up in a new tab so I can actually see what I'm looking at. It's installed before abnormal activity, so we're looking for before 21st of October. These timestamps, so I assume order by that, and I'm assuming it's this drone manager updater. Looks like it could be the size. Drone manager updater. Okay, that is correct. What is the full path where the user launched the application? So that would be assume it's that location. See, that doesn't look correct. Oh, there's confusing. So what is the full path where the user launched the application? Actually, there's one of the keys was for accessing, was it? Like access applications. So I'm assuming that one might show it. So Windows current version. Whereabouts are we? We are uninstall. So we're in current version, uninstall. Let's try Explorer. Actually, no, it would be in the NT user one because that's more about user specific stuff. And let's load in the NT user. Take a look at NT user. Assume software. Let's take a look at the hint. NT data user. Keys, so key stores information on recently accessed stuff. So that's right. Now it's back in the software one in this user system. I think I was going to go for. Let's go back to that. Software, Microsoft, that Windows. Current version. It's current version. It was user assist, which we don't have. Oh, actually I missed Explorer. Explorer, then user assist. No, we don't have. What was the other path that we can go to? The other place we can go is root software. Maybe if I try search user assistant here. Okay, so it is there. Okay, let's look at that. Go order by last executed. We're looking for before the 20th or maybe just here. Okay, this looks like it. Let's see, I think it's this one. And we copy the value. Okay, so I copied it in, but it came out a little weird. So let's just delete all that. Users dispatch and it's documents. Actually, it looks like it's this one. Downloads and then downloads and drone manager. It's got setup.exe. There we go. And which value was added by the application to maintain persistence on startup? Let's do a quick search through here for startup. Go to here. It's this one. If we search for run, and hopefully we can just find that straight away. Maybe I need to add a current version to here. Let's go back to run and it should be in software. So let's scroll through. Microsoft Windows current version run. Microsoft Windows current version. Okay, no, that's wrong. Okay, here's run, and that appears to be the directory. So what exactly did it ask? Which value was added by the application to maintain persistence? Quote C / I think that was program data / is that not right? Program files / drone manager / drone helper.exe. Assuming, let's shrink this to see if it wants the whole thing. It does. So quote -- background. And there we go. That is day 16 of Advent of Cyber 2025 complete. Like this video, make sure to like and subscribe.